guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Boy howdy, do I got an oddball one for me today. So, how do I describe this? I actually own this thing now somehow. It's been a very interesting story on how this thing got to where it's at, but I'm not getting into that. This is where I'm currently at with it. This is a 16 pill. I got no name on it. I have no idea who built it. And it's a fairly recent construction because the case is in really great shape. There's no scratches, dents, dings, or anything on this thing. It's got HG transistors in it, but as you guys can clearly see, it's missing some parts. So my mission, to which I have decided to accept, is I'm going to BBI it and we're going to sell it. So we got 16 new HG transistors in this thing. In fairly good construction. We're going to go through, we're going to change some of the caps, we're going to change the power wire distribution network on this. I would bet money that that's not the stock relay that was in this thing initially. So that has changed, and the combiners were out, they were floating around loose. So I'm not too sure what the whole backstory is at this point. I frankly do not care. That's not my concern. My mission is to go through and make this thing one of mine. That's in a Dave Made style cabinet. It does have a nice rocker switch up here in the front. Which, yeah, it's LED powered, which is kind of cool. Fans are a little bit wee for what we're wanting to do with them, so we're going to put some mega high flow fans on this thing, which will be on the outside of the cabinet. And yeah, we're going to do big power wire and the whole 9 yards to it. So this is where we started. So now I'm going to go through and I'm going to probably take, well, this thing apart, because I want to run the power wires through here. But the nice thing is this thing's got a big giant hunk of heatsink down underneath here. Look at this, whole thing is heatsink. And normally how this comes is there's two split pieces, and the heatsink comes all the way back to here. So this, it's a big hunk of aluminum underneath all 16 of those transistors. So that's a good big heatsink, big heatsink. So we're gonna get rid of these little dinky power distributions. We're gonna put something more into what I am used to doing. New input network, new output network. Pretty straightforward, just get it all cleaned up, but this thing's like 99% new. Let's see if we can go back and put this thing together. So on that note, let me do some magic and I'll catch you up on the next step. You know, I think I'm quite famous for the amplifier pornography that I produce. This ain't that. Yeah. Okay, so this is just the top half. Now, we have the other problem of the heatsink making contact with the wire. So that limits me to 4 power leads. These are tight, this one's spaced, and this one's off spaced for a reason. So the idea is I can bring the wire in and feed this section, bring the wires in, feed this section, then flip-flop the way the power wires are going to come off the board and feed these two sections. So now, and yeah, there's been a few changes here since you've seen it last. There's no cabinet. If you didn't notice. All right. Let's have fun. Okay. Now it's not the heatsink making contact with the wire that I'm so worried about. It's having a sharp edge that'll encroach into the insulation jacket. So I think we've come up with a very simple but clever way of working around that. So we over drilled the heatsink pass-through. We're going to put an extra layer with some insulation of heat shrink on the power wires that are going to feed through the distribution bus. And yeah, the wire will never even make contact with the heatsink going through. This board is so big we're going to jam so much air through it that I don't think that this is going to be a safety issue. So, okay, let's clean up our mess. Believe it or not, dear, there's a reason that I married you. Other than, you know, fine, sexy bud. I do enjoy having your presence. Guys, we're joined by Mrs. BBI. Say hi, baby.
Good afternoon.
Call them gentlemen, fine-haired, dull ladies.
Gentlemen.
So, what we have managed to do is next to the impossible here. We have managed to sneak into the bottom of this through the heatsink with the great advantages of plastics and rubber. I took heat shrink with epoxy in it and double insulated the wire going through the heatsink, over drilled the hole, so it's like, no, seriously, there's literally like a hole this big in comparison to the wire. So there's no chafe point. And then that pass-through point inside the heatsink is epoxied. Now coming out down this fin, as you can see, there's this yellow tape. This is Kapton tape. And you guys that don't know what Kapton tape is, Google it. I'm telling you, you're going to be really impressed. It's got a very high heat tolerance, incredibly low dielectric. So there's no metal actually touching this wire whatsoever. It's all encapsulated in Kapton, which serves as a good insulator. Now, I've got this whole distance from here to the back of the cabinet, and then we're going to pass it through a strain relief. Not the one that came out of the cabinet, because it's woefully inadequate. Where did I put the one that came out of the cabinet? Dear.
I don't know, love.
Your presence of your...
It's distracting.
Man-chesticles. Man-distracting chesticles. It's got me all screwed up. This thing didn't even have a strain relief on it, so what we got to do is I got to go get a body plug for this portion, because the power wires were coming out the top. I don't like doing that. I'm not a fan of that. So the way this is going to sit, it's going to be something like this here. So power wires are going to go whoop, whoop, 1, 2 for the pink, 3 for the stink, right through the hole here, not the bottom side of the cabinet. And we're going to put a strain relief on it. Not this one, because it's too small. So, on that note, on to the next step. Silly, stupid me. Only thinking in two-dimensional space. Where I need to think in four-dimensional. I was informing the boys here on camera, baby, that I'm not too good at my visualization skills today.
No.
I'm not thinking. I want to put another layer of Kapton over the outside of these wires so it can't rub on the cabinet lid that's going to be on top of it.
Mm-hmm.
Smeared.
Smart thinking.
SMMATRNTRTNTTT. Smeared. Someday I'll learn how to visualize things like this. What do you think?
I think you do a pretty good job.
Ah.
See ya.
Love ya. Bye. No rough edges to rub against. Everything is encapsulated inside of an insulator. Alright, so being that this is a Dave-made cabinet, we don't have a lip edge that we have to overcome when we set the heatsink down inside the cabinet. So now what we have is two giant open spaces on the side here that can let air just pour by. I want to maximize the amount of airflow that's going to go through the fins. So, those of you that know me, you already know what I'm going to make and build and put in here next. It's the stuff that you don't see. The stuff you don't see that makes a difference night and day on how things work. Let's go ahead, we'll load this up. And we even took into account the flex of the board. All right. Now every little wind that goes through this thing will go across the heatsink, just like that. Perfect. Perfect. Okay, either I'm going to epically pull this off in one shot, or I'm going to horribly fail. So, here we go. Oh yeah. Work it. Work it. Okay. Work it. Good. 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 Okay. I think we did this. Yeah, I think we did this. Okay. I think I did it. I think I got her pulled off. A little worried about the wires, but until I get this kind of secured, I cannot flip this over. Look at the bottom side. So let's put a couple screws in it. Okay, where to put the other side? Here it is. Oh shit. fit perfectly. Oh yeah. Sweet. Sweet. Okay. All right, sticking one more in a nut. We're home free. We start adding stuff to this, like getting it ready to actually run. There's been a lot of boxes out there built with the power wire looped on the upper side of the RF deck. I'm not a fan of it at all. I think I've only built one like that. I think. Look at that. Oh, that is prettiness. Okay. My biggest concern was that I was going to displace these wires and break our little capped on bubble of love. Nope, not. Here we go. Hey, baby.
I love you. Did you run this one? This one ready to go?
Hold on a second, baby. I'm shooting a video.
I'm sorry.
No. Oh, that's perfect. Cool. All right. Couldn't have come out any better, and there's no air restriction across the back portion of the cabinet. And I couldn't have gotten away with doing this if it wasn't in this particular style of cabinet. Sweet. Air is blocked from rushing up the sides, so when I put the lid down on it, it's like this. Oh, it's going to be tight, but I think you guys can get what I'm going after. The only thing I want to do now is I'm going to put a layer of Kapton tape right down the middle of this thing to make it double insulated. Tap it, tap, tap. Tap it, tap, tap it, tap, tap. Ooh. Like butter. Like butter. Had to give it a motivational seminar. Slid right together then. Imagine that. Okay, let's go play on the top side. Man, I'm sitting here over here just working away. Having fun, making parts, mounting stuff, and I went, oh shit. I gotta shoot me a video. So, where we're at the moment, so went through, and well, let me get you caught up to speed first. We as in the mouse in my pocket, I and the Tooth Fairy went through this thing and started looking at some of the caps that were in here, and now we're going to start changing some of this stuff. Like, there's guys out there that swear by these little blue caps. I don't trust these. I just don't. And I trust these. And after I get each one of these caps here, this part here represents $7.50 after shipping and everything to get it here, just to get it here in taxes. right? $7. But BBI can go to the webpage and I can get it for less than that. Hey, cool, right on, man. That's awesome. After you pay shipping and the taxes on everything to get it here, works out to be about $7. So I'd rather use a higher end component that I can really trust and I know will take the heat. Remember, we're in a cabinet that's only got 2 fans on it, right? Instead of 4. So I have to think along the lines of, well, even though we're going to put big monster fans on it, that some of this stuff might get a little hot, right? So bigger is better. And what I've discovered is higher quality parts, these guys will pay for them. I mean, there's certain dudes out there that'll buy the cheapest thing that money can get them. I get that. I'm not that guy. If you want that, don't come here. And I think everybody's kind of figured that out. So, I mean, it is exhausting. Let me tell you guys. And I mean, it is exhausting to keep all the drawers over here full of whatever little knickknack I need to be able to do Project A today, Project B, Project C. You know, like, I just had to call up and order 100 HGs today. Right? Well, that's great. It's a couple grand worth of money, like almost $4,000. So when I go and I work on John so-and-so's amplifier, I've got the transistors sitting here. Well, it's the same thing. Resistors, capacitors, relays, on-off switches, LEDs, all of that stuff. It's exhausting to stay ahead of all of that. But they make programs for it. Yeah, they do. They make parts tracking programs, and I don't know, man. I'm a small fry shop. I'm the biggest in the world in one aspect, but in another aspect, it's just me. Just sitting here doing my thing. If I had more than just me here, yeah, I'd track every single nut, bolt, and screw. But I just see I'm getting low on something, and turn around and I order a bunch. And usually when I go to order those, I order a bunch of other things too. Make it all kind of come out in a wash, but yeah. We just put $30 worth of parts between here and here. $28 worth of components. Okay? It all adds up. So like this rebuild here is going to cost $400 or $500. Easy. I'm in this thing now. It's 6:30 in the evening. I've been working on this now for 6 hours. I've had to strip the thing completely down and do all this other stuff. Make parts, add parts. It's a lot of work. And now I'm going to go through, I got to change some resistors. Now, I don't know who put this together. I really don't care. It's none of my concern. I'm going to say this. They can solder like a mofo. Because the solder work on the pill strips and around the transistors and those kinds of things, spot on. I'm really impressed with the solder work in here. Really am. And you guys all know that I never say anything negative. It's not my job, not my place, just my job to make the amp work. So for me to say something positive, this dude, whoever built this box, because I don't know, I had no name on it. I've seen a couple that have been produced in the last year or so that look close to this, but they weren't. So I don't know who built this, but I'm here to tell you, the guy that did the solder work initially in these areas, spot on the money, and all the capacitor values and all the resistor values are correct. I know, we took the time to look at them. And the fact they use metal mylars, or metal clad, these caps here, these things are getting incredibly expensive. They're $8 a piece, right? After shipping and tax. I understand why people try to go to these Alibaba capacitors. I do. It's not what I can do though. I can't do that. So we got the whole cabinet back together, back, front, sides on it. We went ahead and hooked the remote back up. We got the whole back of the cabinet completed out. Went ahead and filled the hole over here, which was originally the power wire port. we changed that out and put a body bung there. There was a hole here in this corner of the cabinet. Put a body bung in that, so now it's all nice and clean. On the inside now, there's a running debate going on with us guys, because trust me when I say this, we all talk about how necessary it is to actually ground the cabinet and ground the board. Me personally, I've always done a ground down to the board. The cabinet can carry a lot of juice. It really can if the cabinet's clean. The anodized coating that's on here does not act as that much of a resistor. It is a little bit of a resistor though. But they make up for it in the Dave made cabinets with the bonding to the edge of the cabinets. So I put a strap in it and I bonded it. It's gonna be okay. Boys and girls, it's gonna be okay. So I wish I could have snuck one more piece of 8 gauge in there, but when we stack these on top of each other, that's the maximum thickness that I can go. And if I was to add one more wire, I would have been this tall, and then I would have a chafing and a rub issue on the bottom. So instead of having just one solder point, like I see these guys will bring the wire in on the top side of the box, which I'm not a big fan of. Sometimes the design dictates it, and I've seen a lot of boxes out there running like that. Not saying anything negative. They'll bring a wire in, they'll just bolt it down, or they'll solder it into one end. Well, most of the amperage is going to be down at this end of the board. By the time the voltage and the current gets down here, everything else is drinking at a different rate. The voltage is measured, and when I mean in operation, you can measure it. 14.5, 14 volts, just in the length of the bar. So the whole goal is to stretch out the distribution and make it more uniformly the same length. So we've got a source point here and a source point here and a source point here. That way the amperage doesn't have to travel, the current and the voltage doesn't have to travel that far across the board to make it to where we want to use it. That's the idea. So power switch is all hooked back up. Now I'm going to go in here, I'm going to do the resistor swap. I'm going to change out these 4 resistors, change out this 4 resistors. I went ahead and put the combiner in it, and put the input splitter in it. I got to go through and add capacitance on the inputs. We're going to shoot for a nice 220. I think that will be pretty good. I mean, I was having a discussion the other day about the tuning effect differences that you have with going with higher or lower capacitance. Certain situations, depending on which material make you use on your input and output transformers, how that's going to directly thusly affect your tune, so therefore it'll allow you to have a little bit higher or lower capacitance. I've seen it as high as 280 before it falls in tune. I've seen it as low as 120 before it falls in tune, depending on the surface area of your combiner, depending on the length of your induction, depending on material make of the transformers. You can't, none of these, I guess you could. I guess you could just sit there and just put these together all day long and build one and then copy the crap out of it. But there's too many little fine details in here that I like to tinker with and make sure they're just spot on the money before I can't. I like playing with the minutia of the project, I guess would be the best way to put it. I don't know, I just studied this bipolar push-pull design till the blue in the face. Enough. I gotta keep going. I'm gonna do the resistor swap next, and then I gotta start installing coax. Well, here we are the next morning. Let's see, I think where we left off is the input wasn't in this thing yet. It's now all in. We got a piece of RG400 going across, coming down the end of the cabinet and going over here. All the resistors have been changed. We added a little capacitor bank. Ended up taking the bottom off the amp again and running some wires underneath the board. I didn't want to cross my RF output leads here in the back. Got that all put together. Added a little capacitor bank for a little bit of flare. Added some more capacitors on the power distribution bus. Got that balanced out. Got all the input capacitors on, and about the only thing left to do is to build up our key-in circuit over here in the corner and finish putting together our power wires and get them mounted in. So anyhow, day number 2 ran out of steam yesterday at about, I don't know, 7, 8 o'clock. Went in the house. Ended up having a lot of problems with the lid itself. So it's got a whole bunch of brand new PIM nuts on the bottom to hold the lid on. These the screws that were on the bottom there have been stripped. When the guy put the thing together initially, I think what he did is he took his impact wrench and went, which galled up the threads pretty bad. So, but yeah, give it just a minute and we'll be back. We'll have some power wires hooked up to this thing on the inside and we'll be ready to hook it up and fire down on it. We shall return. Well, it's all done, you guys. Completely rebuilt. Started out with pretty much a blank slate for the most part. I think the main reason this thing was here is because some harmonic issues that was going on with it, and it just got ripped apart because of that. So we're on the cleanest radio on the workbench, which is the derail. Got a 5-watt slug sitting between the 16 pill and the output network here. 5-watt slug in reverse, 1,000-watt slug in average, 1,000-watt slug in peak. So I'll show you drive. Whole whopping like 18, 20 watts, right? Here's our principal. Modulated. So now we're going to show you our span. We're at 55 megahertz wide, 55.82. Nothing pinched, nothing too overly distorted. Let's turn the amp on. About 800 watts. About 200 bird. Less than a half a watt on the input. And that's modulated. Now, we're only putting about a half a watt into this thing. That's why we hear the relay click-clacking so much. So the next step is we're going to bring the 2-pill into line. And once I do that, I'm going to vastly exceed my spectrum analyzer's ability to protect itself. So we're going to shut that down. We're going to kill off the O-scope. Let's go ahead and let's hit this with the bench 2-pill. And let's see what it does. Give me a second. Let me get set up for that. Okay. So now we're metering our voltage from inside the cabinet. We're on 14.2 or 14.4. 1,000-watt slug in the 5x position, so reading 5,000 watts peak. 5,000 watt slug in average. 5-watt slug in reverse back from the bird, 10,000 watt double load. 50-watt slug sitting between the 16 pill with a 3-foot jumper and a 1-foot jumper over to the bench 2 pill attached to the derail radio. So, to establish linearity and for, well, transparency reasons, we got to recreate our results that we had in the last video. So I'm just going to hit it with a straight radio. 2 pill is off. No input reflect. Output power. Right at about 800 watts. Average power. Just a hair over 200. Just like what we've seen in the last video. Oh, now shit. Forgot to show you the voltage. Alright. So we're basically dropping to 14 flat, getting those results. So now, let's turn on the bench 2 pill. So this short of about 500 watts, about 450. 5,000 watts, so I guess 200 watts. Okay, 200 watts average. Check this out. It's 2,400 watts peak. About 13 average. Whole watt in reflect. And let's look at our voltage. 13.3. Trust me, we're going to change that here in a minute. Okay, it's a good input tune, good output tune. Seen about 2,500 watts, 2,400 watts, which is about 400 watts of drive, which is perfect. We're right on track for our benchmark where we want to go. A little low on voltage. We'll get there. Have faith. Okay, so the next thing we got to bring in is the bench 4 pill. So we're going to take the DUL radio, driving the bench 2 pill, driving into the 4 pill, which will make a 2x4, driving into the 16, which will max it out. And then we'll bring our voltage up so it stays above 14 volts, just like it would your mobile, and we'll see what we get out of it for watts. All right, let me add yet another amplifier to the bench. I'm not going to lie to you guys, I'm really excited to see where this is going to run out. Because in the process of playing with it, because each time we go up in a stage, we got to play with it a little bit. We're going down to like 13.8 here. So we've still got a lot of room. And the numbers this thing is producing is matching up with the amps that it's pushing or pulling. So let's let me shut this down over here. And 5,000 watt in PEP, 5,000 watt in average. Okay, so 1,000 watt slug in 5X. Put just close to 1,000 watts into it. All right. Turn the amp on. Now these average numbers are ridiculous to me. Input tune about 4 watts of input reflect. The average numbers to me are ridiculous with these the DUL radio. It's amazing how much bird the thing's doing. Don't get me wrong. But we're going to play with it for a minute, and then we're going to go back to the Joe Schmo radio, which is the 2950. We're going to slam that in here, and we're going to see what the average guy is going to get out of this thing. So let me show you the voltage here. So we're dropping all the way down to 12.9. Look at the amperage that we're drawing. And that's from 1,000 watt dead key rest. Pulling about 100 amps when we key up. So reach down here. This isn't as simple as it seems. Reach down here. I can grab this knob. Turn this up just a little bit. We'll go up to 16.2. We'll see what that gets us. Just a hair over 4,000. Bump this up just a little bit more. 16.2. Go 16.6. So at 14.5, if we can maintain it inside the box. 14.2. About 4,200 peak. And like 3,000 watts average, which is insane. Alright. So we're going to do a couple things here. First, we're going to shut off Superman. Okay. The next thing we're going to do is we're going to disconnect Superman here. I got to be careful because there's no fan on this thing, right? And let's hook up the Every Guy radio. The Everyday Guy radio. Now let's not get any more carried away than this. And I think these are what the numbers that people are going to actually expect to see out of their equipment when they get it on their end. About 2,000 bird. Just a hair over 4,000 peak. It is pulling significantly less amperage though, I will say that. And it's not pulling the voltmeter down the same. But those are realistic numbers. Okay? Those are realistic numbers. Now remember, the voltage that we're reading it from inside the box. Which means we're not reading it at the terminals. We're reading it after it goes through all these different connections and goes across the board and goes... There's loss. That term is called loss. That's the reason I stressed to everybody that, yeah, you might meter your voltage at your battery, or you got a cigarette plug voltmeter that's reading all the electrical in your vehicle. Has nothing to do with the amperage going inside the amp and the volts inside the amplifier. Nothing. It's a significant difference. If I was to measure this over here with the derail radio, it would have told me that we're pulling down to like 15.1 volts. We lose a ton of amperage trying to just simply get the amperage inside the cabinet and the volts inside the cabinet. We lose a bunch. So now what I want to do is I got to do the lid. I'm going to put real big scooching big boy fans on this thing. I'm going to put the lid on this thing. I want to run it for a couple minutes and just see how it does. So let me do the lid. I'll be right back and we're almost done. Well, I got our 2 little jet turbines installed. I love this, you guys. I love that I've got so much work. I love that I got so much to do. And I love that I get little projects like this to do. This thing. Yeah, this has been a fun project. I'd be very careful what I say because I don't want to hurt anybody's feelings, and I just want this thing to be right. Like I say over and over and over again, it's just my job to fix the amp. It's not to get into anything else. This thing is signally pure. It's clean as it's going to get. There's no harmonics in this thing. It's not oscillating. It's building really scary good power. Now that the box has had a chance to cool off, I think you guys are going to be drastically impressed with the difference in the output potential for the unit. Goodbye. Let's put some screws in this thing. That's the other thing I forgot to mention is I went through and with all the popped out screws that I've had, I went through and I replaced all the hardware in the whole amp. So it's got brand new screws all the way around, everywhere, every nut and bolt. So with us knowing that, this has got ICA transformers in it, which are good transformers. They work well. It's got my power distribution network in it. It's got the same transistors in it that I would put in it, the HGs. It's got every cap installed at the value that I would put in it if I was to build it now. I mean, if I was to build this from the outset, I probably would have done a couple different things. Like I would have probably split the heatsink in 2, but this thing has a tremendous heatsink. Tremendous heatsink in it, way oversized, which is good. That's a huge plus. That's the reason we had to put the jet turbine fans on it. There's a little bit more drag on your airflow. Be the best way to put it. So the oversized fans tolerate the back pressure, but also we need that extra volume. Now, we could have picked up a little bit more CFM if I wouldn't have used my classic grill guards that I like. Okay. Would have got a little bit better air pressure through this thing, but in the same breath, I think those wire grill guards are ugly as sin. I like this. This is slick. I really like when I've got 4 openings in the cabinet that are recess cut. It just makes the amplifier look so clean and neat. But here lately, everything that's come through here has been volume, volume, volume of air. This thing's nice. I'm proud to say I worked on this. This is nice. Actually quite happy with this. So, let's do a couple things here. This was hard earned. I think that it might have been a little bit easier, maybe, to strip the amp down with a new board and just start all the way over. But in the same breath, some of the solder work in here was really, really good. I have no problem certifying it as my own. Just generally impressed. Stickers were earned on this box, for sure. Okay. Haven't changed any of our voltages. Haven't changed anything here. So, let's play with this for a minute. 5,000 watt slug and peak, 5,000 an average, 5 watt slug and reverse. Alright. First, to start off with radio drive only. Now we're going to kick on the 2-pill. About 3,000 peak. You see the difference between the box being completely cooled off and it being hot of us beating up on it? I don't like keying it like that. Here, let's key it with 1,000 watts. 3,000 watt dead key. For some reason the mic's wanting to screw up. Let's get our dead key set up here. Set it up around 1,000. This thing's working just like a raped animal. So we're getting our 2200 average out of it with the average Joe radio. Let's call you back, sir. Let's look at the derail radio again and see all the crazy numbers. Drive down. This scares me. Look at this. 5,000 watt slug and average. Peak numbers 5,000 watts. RF we quit getting in the mic. That's from a 2,000 watt dead key going forward to 3,200 watts. Moral of the story is this thing's right. It's running crazy. Oversized heat sink and every single thing has been meticulously gone over. The cabinet is in new shape, absolutely new condition. No scratches, no dents, no dings. Guys, we're going to ask $2,200 for this. Period. So if you're interested, text me or call me. We'll get this thing shipped out to you on Monday. It's a little bit too late in the day. By the time we get the video done, it'll be after 5 here. So, guys, I appreciate you tuning in to watch the entire rebuild on this 16-pill. It is what it is. $2,200. Gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out. Facebook, Twitter, Snapchat, Instagram, right here on the YouTube Garler. If you like what you've seen and seen what you liked, take a hot second. Click subscribe. This was a fun one. It took a long time because I had to take so much stuff apart and check it and then put it back together, but it was worth it. Somebody's going to get themselves a nice 16-pill and a Dave Made cabinet with oversized fans. I got to go. Appreciate you guys. See ya. Bye.